number B, we have the following figure. So this is our fixed point. We have point O here, and then we have a force acting on the opposite direction, and the force we are given as 30 newtons. We have also been given the distance, this distance here. The distance here we have been given as 20 centimeters. This distance is 20 centimeters. And we are told that this is the pivot. So that's what we have. We want to calculate the moment. So when you are told to calculate the moment, the first thing we need to write the formula for moment. So moment will be equal to force multiplied by distance. So we need to ask ourselves, what is the force? We have a force of 30 newtons. Then what is the distance? And now, remember we are talking of the perpendicular distance from the point of support to the line of action. So we need to know, where is our point of support? Our point of support is here. Where is the line of action? Our line of action is here. This line of action. So if I may ask you, what is the distance between from the point of support to the line of action? What is the distance there? The distance is 0 because the force is being applied at the point of support, and therefore the distance covered is 0 meters. We can talk of meters, 0 meters, and therefore our moment will be 0 Newton meters, meaning that there is no turning effect. This can be seen whereby if you try to apply force on the hinges of a door, you apply force on the hinges. What is going to happen to the door? There is nothing that is going to happen to that door. It is not going to open, nor is it going to close, because you have applied the force at the hinges, at the point of support, and therefore the distance is 0. So our moment will be 0, meaning that there will be no turning effect. I think that is clear. So finally, we can do another example. Number C, we have the following figure. We still want to calculate the moment. So that's what we have. And we have been told that the distance is 5 meters from this point here. This is where our pivot is, this point O. And we have been told that the distance from the pivot to where the force is being applied, you can see how this force is. Look at the force. Here we have the force, and the force is 6 newtons. The distance here, this distance we have been given as 5 meters. This distance is 5 meters. We've also been given this other distance here. We have extended this from this point, and we have been told that this makes an angle of 90 degrees, and the distance here from this point all the way to this point we have been given as 3 meters. We have 3 meters, and now we want to calculate the moment. So you can see in our case here, we are having the point of support here. We have the distance from here to this force, but this force, as you can see, is acting in this direction. So you can see that this distance from here up to here is not the perpendicular distance. From the point of support to the line of action, our perpendicular distance is this. This is the perpendicular distance. So we are going to consider this perpendicular distance from the point of support to the line of action. This is the perpendicular distance D. So make note of that. So the distance that we are going to use is the distance which is perpendicular to the line of action. So we need to calculate this D. We know that these are right angled. We have 5 here, we have 3, and we have this side. So then that means that this is our hypotenuse, 5. Then we have one of the sides as 3 meters. We want to get D. So using the Pythagoras theorem, we'll have that 5 squared will be equal to 3 squared plus D squared. So we are going to have this as 25 equal to 9 plus D squared. So when we make D squared the subject, we are going to have that D squared will be equal to 25 minus 9, which is 16. So our D squared is equal to 16, and therefore if we have D squared to be 16, then we can find the value of D. So D squared is equal to 16. We find square root on both sides. So our D will be equal to the square root of 16, which is 4. And in our case, we have it in meters. And therefore, we can now come and calculate moment. So moment will therefore be equal to force multiplied by the perpendicular distance from the point of support to the line of action. So our force being applied is 6 newtons, and the perpendicular distance, we have gotten it to be 4 meters. And therefore, moment will be equal to 24 Newton meters. Is that one clear? So when you calculate moment, you need to remember that we use the perpendicular distance from the point of support to the line of action. And moment is given in Newton meters. Again, if you look at this example here, when you apply force to the fixed point, or you apply force on the fixed point, there is no turning effect that is going to be obtained. So that's why in our case here, if the force is being applied at the same point where the pivot is, then we are going to have a moment of 0, meaning that there will be no turning. And that's why we were saying the more the distance from the hinges, the more the moment. And simply when we talk of the more the moment, it simply means the more the turning. And that's why we were saying that the hinges of a door are placed as far as possible from the handle or from where you open the door from, so as to lead to more turning, because the moment will be more. And that's why there will be more turning of that door. So that is on moment. You can get more questions on moment and calculate. So this will usher us into now a principle which we refer to as the principle of moments, and that's what we want to state.